Hello, everyone. Welcome back to Chapter 11 Chem 2C stuff on electrochemical cells. And this time we're going to be talking about electrolysis, which is associated with electrolytic cells. And if you remember before, I think one of the first videos we did on this chapter, it was galvanic cells. And I did remember saying something about how there are two different kinds of cells, and we're going to get on the other one later. Well, this is the other one, which is electrolytic cells. So galvanic cells is when you combine two cells basically. So say zinc is here and copper is here, 2 plus, and then the whole electrode thing, copper, zinc, and the electrons are transferring from here to here, and it's a spontaneous reaction. So the E is going to be positive. I'm combining concepts from multiple different videos or things that at this point of the class you should know. If you don't remember, you can go back and watch the videos that I made previously. But in spontaneous cells, the E is positive. And remember, the E is equal to the E of the cathode minus the energy of the anode. So this minus this. So let's say zinc, which is the anode, is negative 0.76, which it actually is this time, and the copper, which is the cathode, is 0.34. The E on this reaction would be 0.34 minus negative 0.76, and it's going to be added, so it's going to equal 1.10 volts when you add these two numbers. And then this is a galvanic cell, but then in the electrolytic cell, it's the opposite. So this is still going to be the anode, and this is also still going to be, that's a lot bigger, doesn't matter though, the cathode. But this time, for let's say it's still the same reaction, this time it's going to be the copper is in the anode and the zinc is in the cathode. And the reason why is because the electrons are still going to transfer, but as you know now, since in this situation it was spontaneous, in this situation it's not going to be spontaneous. So because when you do the E, it will be the cathode minus anode, so it will be negative 0.76 minus positive 0.34. It's going to be negative 1.10 volts. So as you notice now, the E is negative now in a electrolytic cell. So that means this reaction is going to be non-spontaneous. And if it's non-spontaneous, that means the electrons aren't going to move. So what happens in electrolytic cell is that you need an outside source of energy to put in a certain amount of energy in to get the electrons to flow. So let's say you want the electrons to flow anyways, but then the reaction is not going to happen on its own. You have to push the reaction. And it goes back to my whole explanation of spontaneity, like the analogy that I used to remember spontaneity. Imagine up a hill. You have to push a ball up a hill. Let me start with spontaneous. Spontaneous reactions, the ball is up here. And if you let the ball go, it's just going to drop on its own. That's how the ball would work. But for non-spontaneous reactions, imagine the ball starting at the bottom of the hill instead of the top. This time, it's not going to, like, if you put a ball at the bottom of the hill, the ball isn't magically going to go up. You have to physically push the ball up on your own. So let's have a little person here pushing the ball up for it to go up. So it's the same idea in electrolytic cells. The electrons aren't going to transfer on their own. They have to have somebody push them. So some source or some outside energy, which is, I forgot what it's called, but something here that provides energy, usually given in like amps, which is another unit of energy for electricity. And if you put that into the cell, then it's going to prompt the electrons to now move. So I'm going to get into electrolytic stoichiometry to explain how you would do a word problem based off this. So over here is the electrolytic, the whole stoichiometry. So we can either transfer this direction or go from this direction to this direction. So if you're given the amount of charge, for example, this next question we're going to get into it. If you're given the charge, that means you have to move towards this direction to find the grams, to find the moles, to find the whatsoever. Usually you start here and then you go here, or you start with the grams and you'd have to find the charge of the seconds or whatever. So, and the important thing about this is to look at the units. That's what usually helps me. So like on a test, I'm not gonna write all this out. I'm just writing this out to explain it. But the way that I remember is through the units. So for example, amps, I know the amps, like I wrote here, is 1 coulomb per second, 1 second. So if I want to transfer it to coulombs, I multiply by seconds. And then if you do that, you notice the seconds cancel out and you're left with coulombs. Coulombs here, I mean. And now if you want to go from coulombs to moles of electrons over here, you divide by, I didn't put it on here, but there is something called a Faraday's constant, which is 96485 coulombs over moles of E. You don't have to remember this number. It'll probably be given on the test. You just have to know that this is a Faraday's constant and you have to use it if, well, in this context specifically. So over here, if you look at the units, the C, if you want to go from this to this, you have to cancel the C out and leave the E. So you have to flip this upside down because, you know, we're trying to cancel the C out. And if we do that, I'm going to rewrite it all. So we have to put it this way, mole of E divided by 96485 coulombs. And now in this capacity, the C's cancel out and you're left with moles of E as the unit. And now you have moles of E and moles of electrons. If you want to transfer moles of electrons to moles of elements, you just, I think you multiply. Let me think about it. So let's say you have something, you have a certain amount, let's say 2 moles of electrons, and you want to transfer it to moles of element, you divide it by 1 mole of electrons, not 1 mole, 1 mole of the element. You see, this will make sense when I do an actual problem. So let's say the element, like here, zinc, you go 1 mole of zinc. And how many electrons did that mole of zinc has? In this scenario, it has 2. But it can have like usually 2, 1, 3, etc. So you divide it by, let's say, 2 moles of electrons. And you'd notice the moles of electrons down here. Write it out again. The mole E would cancel out with each other. And now you're left with a certain number of moles of said element. And then, you know, you use the molar mass to get the grams. You just, so molar mass is given in use of grams per mole. And you want grams, so you just multiply it by grams per mole. So the moles cancel out and you're left with just grams of the element. And that's how you convert it using units. You just have to remember the units and you know whether to multiply or whether to divide to cancel out and get the units that you desire. So over here to do example problem, over here we're asked for seconds. So straight off the bat, I know we're looking for this, so most likely we're going to be moving this way. And we're given the grams, okay, so we can find the moles now given the grams of the zinc metal, and then we're also given the moles of electron right here. Sometimes they can also give you like the 2 different equations, and then you like do both of them plus 2E, and then let's use copper again. And then you're given this. You have to realize on your own that the moles of E, the mole of electrons is 2 because they both have 2. And if one of them, let's say, hypothetically, copper or some random element, use a random element, like let's say element X was element X plus, and then you have plus only 1 electron being transferred, you'd still use 2 because it's the highest one. You have to use the highest one. So you have to multiply by 2, multiply the whole thing by 2, and then this will become 2E, and then it will still be 2. But let's say this was 3. Let's say the element had a charge of 3 plus, so then it would be 3 plus 3E. What would the mole of E be? It'll be the you have to multiply these 2, top equation and the bottom equation, to give you 1E. So straight off the bat, I can look at it and know you have to multiply this one by 3 and multiply this one by 2. So then they both give you 6 electrons. 6 electrons, and then you use 6 electrons. And that's how you determine the moles of electrons. So I'm going to erase it down and go on and actually do the problem. So if we look over to the problem, we know from just mental math that we can get from here to here to here to here, and then we can get to here because this is a constant. So and we're given the current A. And we have to remember amperes is coulombs per second, and we're looking for the bottom one. We're looking for the second. So eventually, we just have, if we follow the right units, we should be able to flip it. So I'm going to start on this end. So we're going to start, we're given with the grams. So first I'm going to go from grams to moles. And if we have 0.240 grams, and remember I said the key thing to do here is track the units. If you track the unit, you should most likely get the right answer. Because then if the units don't cancel out, you know you messed something up and you have to go back and make sure the units cancel out and you're left with the right one in the end. So over here we're given grams, and then we have to convert it to moles. And how do we convert it to moles? Using the molar mass. And the molar mass has units of grams per moles. But if we notice here, if we put the grams per moles at the top, so if we multiplied it, we would notice that the moles, it wouldn't have a unit of moles. It would have a unit of grams square over moles, which we don't want. We want the grams to cancel out and be left with the moles. So we have to flip this equation. I mean, not the equation, flip the grams per moles and put it at the bottom. So it becomes moles over 65.4 grams. So now you know that the grams are going to cancel out and you're going to get moles. So now we know we're going to get moles, but we want moles. So we have them. We're at this part now. We're at moles of the elements now. And now we want the moles of electron. So we look over here. And then what we do is we multiply it by, remember I said earlier, the zinc. So since it's 2+, that means it'll have 2 moles of electrons. And we want to cancel out the moles. So we put the moles on the bottom, and it's per 1 mole of the element times 2 moles of the electron, mole of E negative. Since, remember, it's 2+, so we're multiplying by 2. So now we have units, so let's cancel it out. Cancel the moles out, and you're left with moles of E. Remember, the moles of E is the only unit that hasn't been canceled out yet. So that means right now you're in the moles of E, so you're on this stage. And now you want to go from this stage to this stage, the quantity of coulombs. And remember what I told you about, there's a Coulomb constant that helps you cancel out the moles of E, and you're left with C. So you want to leave it in units of coulombs so you can find the amp. So you can use, since coulombs is here, we want to find this coulombs that we can use in this equation. So we cancel out the moles of E by, so we have the Coulomb constant, which is 96485 C over moles of E. Oh, I was going to say, how do I put it? But you can already see that it should be in this format. So the moles of electrons are able to cancel out. So we should be, this is the right format to put it. And then if you look at it, you see that the moles of electrons do cancel out. And remember the C's here. The units are coulombs over moles of electrons. So now we're left with all the other units are canceled out except coulombs. So now we have coulombs, and now we have to figure out the type of math we have to do to cancel out the coulombs and be left with seconds. And let's say hypothetically this question asks how many amps. So what would be the final, would I say, current? So how many amps? We'll just multiply it, or I mean we'll just divide it by seconds. So we'll just divide it by so and so seconds to get coulombs over seconds. But we're not looking for coulombs over seconds. We're just looking for purely seconds. And how we do that is, remember, we have this number here, 0.988 A, and I told you A is the same thing as coulombs per second. So you can just change this units into coulombs per second. And now we have the unit seconds that we want the final answer to be. And then, but we have to figure out a way to convert what unit of math, what application of math are we going to do to get the C to cancel out and be left with seconds at the top. So let me put it on here, 0.988 coulombs over seconds. Over here, the coulombs don't cancel out. So that means we have to put the equation, this upside down. So we have to put the seconds at the top. And when we put the seconds at the top, that means it becomes a division, but we're all multiplying it. So we just flip it and it becomes 0.988 coulombs. And now this is the desired equation because the coulombs cancel out and you're left with just seconds. So whatever answer you get at the end is going to be seconds, which is what the answer is asking for in seconds. If the answer was asking for how many minutes are required, you just divide it by 60 because they're 1 minute for every minute, there's 60 seconds. And then you divide the amount of seconds by 60 and you get the answer in minutes. But we don't have to do that because we're just asked for the answer in seconds. So we just divide this number actually we multiply all this, and then finally we should be left with units of S, seconds, and that should be the final answer. I'm just gonna plug into the calculator and do it for you guys. And in the end, I got 716.7 seconds, which I could just round up to 717 seconds. And that should be the right answer. So I just did this divided by that times this times that divided by that, and I got the final answer. Now I'm going to do an example to go from charge to mass. Over here it asks how many grams, so we should leave our answer in grams, of iron metal will be deposited from a solution that contains Fe. The moles of E is 2 from this. Well, it's not. Anyways, the moles of E is 2. It's not writing over. If a current of this is applied for this amount of time. So first of all, I'm going to be quick with this since I hope you already understood it from the last example. But A is equal to current over seconds, and then since the time, we have to find, we're looking for the coulombs, you know, because we're going this way. We have to transfer it to coulombs. In order to get the coulombs, we have to do this divided by, or we'll see. But first of all, the first thing I know for sure is we can't have this answer in minutes, so I'm just going to convert it into seconds, which is just multiplied by 60, and that is equal to 2,562 seconds. So we have over here, the amp is, we have to convert it to coulombs physically. And since we have 0.843A is equal to C over 2,562, and we're looking for C, it's just this divided by that. Algebra, you move the seconds over, that means coulomb is equal to 0.843 over 2,562, which we can actually do right now by plugging in into the calculator. So we get the coulombs is equal to 3.29 times 10 to the negative 4 coulombs. And then now we have the coulombs, we keep going, we'll transfer it to moles of electron, and we still use Faraday's constant to transfer it to moles of electron, so we just divide it by that. So it's, you remember Faraday's constant is coulombs over moles, but this time we're going backwards, so it becomes moles of electrons over 96485 coulombs. So we can get this to cancel out, and now we have just moles of E left. And now with moles of E, we transfer it to regular moles, and to transfer it to regular moles, you put moles of E at the bottom, so it's regular moles at the top, 1 mole of iron, and each mole of iron has 2 moles of electron because it's a +2 charge. So you divide it this time. Last time it was multiplied, this time it's divided. So it's just the opposite of whatever we did here. So we divide it by 2 moles of electrons, and then from moles of electrons, we go to, we cancel out the moles of electrons. So we go straight into, this part was finding the moles of electrons. Now we find that we have the moles of elements, and with the moles of elements, we can find the grams, because we have the moles, and grams per moles, we use grams per moles. And to cancel out the moles, we have to put the grams at the top. So 55.9 grams at the top, and then moles at the bottom, mole of iron. And the moles cancel out. And now you're left with this. You just do all this process, plug into the calculator to get the final answer. When I did all this, I got a really weird number, which made me to realize that I did make a mistake. And algebra, you don't divide it over here. I messed up the coulombs. The coulombs should never be that low, since we have to divide it also by this. So the coulombs is actually multiplied, so it's 0.843 multiplied by 2,562 instead, because you have to multiply both sides in algebra. Look at me, I did algebra wrong. So when we multiply these two together, we get 2,000, so a much higher number instead. And I'm gonna write it down here. So it's 2,159.8 coulombs, and the coulombs still cancel out. And when we plug all of it into the calculator, we get 0.626 grams of iron, which does look like a right answer, because we shouldn't get times 10 to the negative grams. That's just way too little. So this makes sense. And that is it.